All right, so I'm gonna get started. So today we're gonna continue on with these reference angles. So we can use reference angles to evaluate our trig functions. If we're given a angle that is greater than 90 or less than 0. So you can use reference angles to evaluate trig functions for any angle theta. The sign of a function is determined by the quadrant in which the terminal side of theta lies. So again, your quadrants, you have quadrant 1, 2, 3, and 4 laid out for you here. Now if you want to find, say, sine of theta in quadrant 3. So sine of theta in quadrant 3 is here. It's going to be negative. Okay, so that's what that means when you're using this chart here. Say you want to find sine of theta in quadrant 2. Well, sine of theta is here in quadrant 2. That's going to be positive. Okay, so that's how you kind of read this chart here. So you want to look which quadrant is my terminal side in. Okay, am I trying to find sine? Am I trying to find tangent, cosecant, cotangent, whatever it is? And then you want to find that quadrant, find, say, cosine in quadrant 4. Okay, cosine in quadrant 4 would be here, and that's positive. Okay. Now, evaluating these trig functions, you have 3 steps. First step is to find the measure of the reference angle theta prime. That's what we did yesterday. Okay, so we found the reference angle. That's that angle between 0 and 90. Okay, so it has to be an acute angle. Step 2 is to evaluate the trig function for theta prime. Okay, so we're going to keep it in exact values because we're working with 45, 45, 90, and 30, 60, 90 triangles. And I'm going to rewrite all of those down on your note sheet. Step 3 is to then determine the sign of the trig function value and use the quadrant in which the terminal side of theta lies. So that's where that chart comes in here then. Okay, so we will be using the relationships of special right triangles to determine the trig values for special angles. So in a 30, 60, 90 right triangle, sine of 60, okay, if I go from the angle 60 here, sine is opposite over hypotenuse, so this is going to be square root of 3 over 2. Okay, so if I say find sine of 60 degrees, you would say that's square root of 3 over 2 as your answer. Okay, cosine of 60. Cosine is adjacent over hypotenuse. If I have an x over an x, they cancel. So this would be 1 over 2. Okay, so if I asked you to find cosine of 60 degrees, you'd say it's 1/2. Then tangent of 60 is going to be equal to just the square root of 3. Okay, and remember you can also have cosecant of 60, which is just the reciprocal of sine. Secant of 60 is reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so remember you can do that as well. Now with 30 degrees, if I say find the sine of 30 degrees, okay, that's going to be equal to 1/2. Okay, then cosine of 30 degrees is square root of 3 over 2. And tangent of 30 degrees is equal to the square root of 3 over 3. Okay, we just want to rewrite these out so that you guys have that as we do these problems today. Okay, that's for a 30, 60, 90. Then for 45, 45, 90, we'll have sine of 45. Okay, sine of 45 is equal to the square root of 2 over 2. Cosine of 45 is also equal to the square root of 2 over 2. And tangent of 45 is equal to 1. Okay, so today you're going to use these. So what we're going to do, so if you look at the examples below there, we want to find the exact values for each trig function. So that first one is cosine of 135. Now we can't take cosine of 135 because that angle is not between 0 and 90. So that's where that reference angle comes into play that we found yesterday. Okay, so the first thing that I want to do, just so I know what quadrant that angle's in, we're going to draw out our mini graph here, and I want to see where that angle would be. So I know 135 is greater than 90, so it has to go past 90. But it's also less than 180, which is this line right here. So it's going to be somewhere right here. Okay? So my terminal side of that angle would be in quadrant 2. Okay, so we have quadrant 2. So again, our step 1 to solve these problems is to find the reference angle. Okay, so that's what that chart on the top of our note sheet says. Find the reference angle. That's what we did yesterday in class. So now since we're in quadrant 2, okay, quadrant 2, to find theta prime, we need to take 180 minus our original theta value. Okay, so we'll take theta prime, it's 180, minus our original theta value, which is 135. Okay, so theta prime will be 45 degrees. So now, step 2 is to evaluate the trig function for theta prime. So now instead of cosine of 135, I want to find cosine of theta prime, which is 45. Okay, so cosine of 45, if I look up what I wrote here, my 45s are over here. Cosine of 45 is square root of 2 over 2. Okay, last step, step 3, is to see which quadrant my angle is in, right? Which quadrant are we in? 2. So I'm going to look up at my chart here. Quadrant 2. I'm finding cosine. So look for cosine. Cosine is right here. So cosine in quadrant 2 is going to be negative. Okay, so our final answer for cosine of 45 is going to be negative square root of 2 over 2. Okay, since we were in quadrant 2, cosine is negative in quadrant 2, so I just need to find the sign for step 3 there. And that would be your final answer. All right, questions on how I found cosine of 135 by finding that reference angle? Hey, shh. Are you paying attention?
We're in a conversation here.
Yeah, I know you are. All right, then next one we have is cotangent of 7 pi over 3. Okay, so if you want to, you can change it to degrees right away. I'm not going to change it to degrees right away because I know where 7 pi over 3 is. So first thing that I want to do here is, again, find where my angle is on my graph. Okay? So I have my graph. So 7 pi over 3 is greater than pi over 2. Okay, so I have to go past that. Is 7 pi over 3 greater than 1 pi? Yes, because 1 pi would be 3 pi over 3, right? And 7 pi over 3 is way greater than 3 pi over 3. Okay? I do have to keep going.
Stop.
Past 6. Come on, guys.
It's past 6. Okay, so if you have 6 pi over 3, that is 2 pi. Okay? 2 pi is a full circle. 7 pi over 3 is greater than 6 pi over 3. So that's why it's going to end up going around once, okay, and end up in quadrant 1. Now, again, if you want to find out the degrees right away, if you think that's easier, take 7 pi over 3 and multiply by 180 over pi. And you'll figure out that degree measure, and then it might be easier for you to graph. Okay, so just change it to degrees, because we're going to need it in degrees anyways eventually here. So since this is over 2 pi, so it's greater than 360. Okay, it's greater than 360. That means my next step is going to be to find a coterminal angle, not the reference angle. So for this one, we need a coterminal angle first. Okay, since it's greater than 2 pi or 360, to find that coterminal angle between 0 and 360 or 0 and 2 pi, I'm going to take this 7 pi over 3 and subtract 2 pi from it. Okay, if you put it into degrees, you would subtract 360 from it. Okay, so now this is 2 pi over 1. What do I have to do to combine these two?
2 pi over 2.
No. You have to multiply by 3 to both the numerator and denominator here. So minus 6 pi over 3. Okay, so this is going to be equal to pi over 3. Okay, so that's my coterminal angle. Now, I'm going to go through the steps just like I did here to figure out the rest of this problem. Okay, so step 1 is to find your reference angle. So reference angle is, again, what we did yesterday. Now this is in which quadrant? What quadrant is this?
4.
No. No. What quadrant is this?
1.
Okay, so this is in quadrant 1. If I look at my quadrant 1 from yesterday, theta prime is just equal to theta. Okay, so what's my theta value? Yes. So our theta prime is going to be pi over 3 since it's just equal to theta in quadrant 1. Okay, step 2 is to evaluate using your reference angle. So we are taking cotangent of pi over 3. Now, what is pi over 3 in degrees?
Let's see here, what's 180 times 3?
Divided by 3.
Divided by 3, see the difference?
What's 180 divided by 3?
60.
Yes. Okay, so if I change pi over 3 to degrees, okay, change pi over 3 to degrees, you get cotangent of 60. Okay, so pi over 3 is the same as 60 degrees. Okay, now, what is cotangent of 60? How could I figure that out given my special right triangle stuff up here?
1 over 2.
See over there,
Cotangent, not cosine.
Oh,
Oh, two, wait, no,
square root of 3.
it'd just be, 1 over
Square root of 3.
the
2 over
square
3.
root.
Yes. So since tangent of 60 is the square root of 3, and I'm finding cotangent of 60, you need to take the reciprocal of tangent of 60. So that means I would end up with,
Square root of 3 over 3.
1 square root of 3 over 1, or over 3.
okay, so I have 1 over the square root of 3. Now I don't want that in the denominator, right? So we multiply by square root of 3 over square root of 3. And yes, that's, I know. You get square root of 3 over 3.
I don't know why I said that like 5.
I know, I'm showing everybody else in case they didn't
yeah, we're
understand
a little
why.
slower than you, Ethan.
So,
The cotangent.
no, it's not. Tangent of 30 is up there, which is cotangent.
It's the same thing as
I know.
Same thing.
All right, so that was step 2. Step 3.
What? I already.
Step 3 isn't that difficult. Okay, so step 3 is where you have to look at that chart above on this note sheet. Okay, so I'm in quadrant 1, right? Quadrant 1
Yep.
and cotangent.
Yep.
So up here, look for quadrant 1, look for cotangent. What sign does that have?
Positive.
It is positive.
They're all positive.
Okay, cotangent, quadrant 1 is positive. So we do end up with the square root of 3 over 3.
that all.
Something happening. Okay, questions on those two problems. So again, if you want to change your radians right away to degrees because you think that's easier, do that. Okay, and then just do the same process without the radians but with degrees. Okay, you'll get the same answer.